My name is Weiming Zhi, and I'm from the University of Sydney, and today I'll be talking about my work on probabilistic learning of motion patterns. So the main theme behind the research that I'll be talking about is that we're trying to capture motion patterns in dynamic environments under the presence of moving agents. And we have the need to accurately quantify uncertainty as well as to obtain continuous representations that don't discretize the environment. I'm going to be introducing continuous spatial temporal directional maps. So given data about movement directions of agents in an environment, we can create a spatial temporal model such that if we give any point in space and time, we can get a distribution of future movement directions that are wrapped around negative pi to pi. So if we query across space at a given time, we get the figure on the right. And if we query at fixed points in space and at different times, we can see different directional distributions as shown on the left. Then we want to extend from just predicting directions to entire motion trajectories. So we introduce kernel trajectory maps, which allow us to condition on arbitrary length trajectories that we observe to predict future trajectories. In fact, the distribution of future trajectories represented as a multimodal stochastic process, with each sample of the stochastic process being a continuous function that represents a motion trajectory. So the methods that we just described about uses mainly or purely learning methods. And we introduced the combined learning and optimization method such that what we predict is compliant with the existing environmental structure. So the predicted trajectories aren't likely to go into obstacles. So on the left figure, we see that the magenta distribution of trajectories is not environmentally compliant, while the cyan distribution of trajectories complies with the environmental structure. And you can see the same on the right, with these red trajectories running into obstacles, while these green trajectories utilize our framework and don't. So in the future, I'd like to work on fast planning methods that utilize the prediction models that we just introduced, as well as quantification of different sources of uncertainty. Thanks for listening.